So we have an integration question here where we've been given a definite integral being one where you have limits of integration, in this case b and 0, and we're told the solution to this. We're told that the answer to this question is e, and we have to solve for the only unknown in the question, which is b. So it looks like there's a lot going on, but remember e is just a constant number, Euler's constant 2.718, and it continues forever. And we're trying to find what b is, b being the only unknown in the question. So let's go ahead. We need to know our rules of integration of exponential functions, so we can find those in our formula books. And let's just do a quick summary of it. So if we had the integral of e to the x, we can open up our formula and tables book, and we know that the integral of e to the x is e to the x. Now we won't worry about the constant of integration because we do have limits in this question, so we'll get rid of that, but we know that that would be there in a question where we don't have the limits of integration, where it's an indefinite integral. Okay, well what about if you change the exponent, this power, if we change that to something other than an x, so for example 2x, well then the rule is that the integral of e to the 2x is e to the 2x divided by the derivative of the exponent, and the derivative of 2x is 2. Similarly, we could have e to the minus 5x, and the integral of that would be e to the minus 5x divided by the derivative of minus 5x, which is minus 5, and so on. Now our formula book does have this e to the ax, and it tells us that that is 1 over a e to the ax, which is a fine way of doing it as well. That's fine. If I was doing e to the ax, I could say that that's e to the ax. So I like thinking about it in the way that it stays the same and then divided by the derivative of ax, which is just a. And e to the ax over a is the same as saying 1 over a e to the ax. So whatever way you break it down, you get the same thing. Well, what about the one that we have? Well, the first thing I would say is b is just a constant. Now, one of the rules with integrals is that a constant can be brought out the front, so we can think of this as b times the integral from b to 0 of e to the bx dx. That's fine, and that's equal to e. Or we can just leave it where it is, and I'm just going to leave it where it is, and I'm going to say that the integral of b e to the power of bx is b e to the power of bx divided by b. And then we're going to go from 0 to b. We're going to sub those numbers in a second, and that's equal to e. So we can see that these b's are going to cancel, first of all, and so we're left with e to the bx. And again, we're going to sub in the limits of integration b and 0 and let it equal to e. So I'm subbing b and 0 in for x. So it's e to the b times b minus e to the b times 0, and that's equal to e. Well, e to the b times b is e to the b squared minus e to the 0. B times 0 is 0. Remember that e to the power of 0, anything to the power of 0 is equal to 1. So I'm going to change the e to the power of 0 equals 1. And we'll pause here for a second, and remember, what are we trying to find here? We're trying to isolate or find this b. So we have the minus 1 on the left hand side, so if we add 1 to both sides, we'll have e to the b squared is equal to e plus 1. And what we can do now is we can use our rules of logs to rearrange this so that it's in log form. Okay, so if we apply that rule, I do kind of say we kick the exponent out, so that becomes the b squared equals the e becomes the base of the log, and then we have the e plus 1 here. So you'll have your own way of remembering how to rearrange from exponent form into logarithmic form. That's the way that I do it. So b squared is equal to the log of e plus 1 to the base e. Now a log to a base e, remember that's the natural log, so it's up to yourself. You can put in ln instead of log to the base e. It might be easier when you go to put that into the calculator. So b squared is equal to the natural log of e plus 1, and then b is obviously the square root of the natural log of e plus 1. And the reason I've put a plus there is because we are told in the question that b is a positive constant, and so it's only the plus version of this root. And then if we throw that into the calculator, we get that b is equal to 1.145976303. They don't actually say to how many decimal places. So where they don't say, you're better off writing down as many as you can.